Okay, so we're back. So now we are going to do a deeper dive on monopoly. This is an extension of everything that you've learned so far on the simple single product monopoly case, where that again to rehash the central issue with the monopolist is every time he wants to increase by 1 unit his sales, the price of all the units go down. So there is a cost and a benefit to selling more, which is why he doesn't sell as much as the perfectly competitive firm. Okay. So in this case, we will talk about first about price discrimination and how price discrimination is something that a firm with monopoly power can execute. Here specifically, we'll be talking about third degree price discrimination. A little bit of an admin note. We will not be discussing everything in these slides. Specifically, I will be skipping product variety and group pricing and differentiation by location. Okay, so let's go to price discrimination. What is the definition of price discrimination? It is when the seller sells the same product to different buyers at different prices. So the key here is key conceptual idea here is that the difference in the price is really due to differences in the consumers and how the monopolist or the firm with market power is trying to sell to different consumers because they have different willingnesses to pay, right? Different demand functions. And this is not a story about differing costs to sell to different consumers. Okay. So the use of price discrimination raises two questions. So this is the general concept or issue or problem when it comes to price discrimination. First, what market conditions make price discrimination feasible, and what makes it profitable? Okay. So let's talk about feasibility. Okay. Textbook monopoly charges one price. Again, the firm lowers its price not only to the consumer who buys the marginal unit, but to all other consumers as well. So it constrains the firm's ability to convert consumer surplus into profit. Okay. So remember, if you remember that demand and supply triangle, total surplus is maximized when price equals marginal cost. And if it's possible for the monopolist to get that consumer surplus, the top half of the triangle, then that's good for the monopolist. Yeah, but then he cannot because of that fundamental trade-off that we were talking about. So there are two obstacles to price discrimination: the ability to offer different prices again based on the consumer characteristics. Okay. First is identification. You must be able to identify who is who on the market demand curve. So you have to be able to identify the high value types and the low demand types, and you have to be able to do it without basically uh, getting too much information because that would be very difficult and very costly. So identification should be a feasible thing and should be even possible. Next is arbitrage. So when, for example, a low value consumer buys the product at a lower price, then he might offer or resell that product to a high value consumer. Okay, in which case it will be impossible for the monopolist to continue offering two prices because the consumers would simply just resell. And if the high value consumer realizes that there is a source of the product from the low value consumers, he will simply not buy at a high price from the monopolist. So that undoes the possibility of price discrimination. So identification. Okay. The common assumption in the textbook monopoly model, firm knows the quantity demanded at each price and therefore the marginal revenue curve. With uniform pricing, all that's required is how willingness to pay in the overall market varies with the quantity of goods sold, which is the demand function. To price discriminate, monopolists should know how different kinds of consumers differ in their demand for the good. Okay? So sometimes identification is not easy to overcome. Okay, it's easier for some sellers than others, especially with those with personal knowledge of the clients, but not for others. Some techniques, there are some conduct that enables firms to be able to identify what kind of consumer they're dealing with, such as weekend sales or offering coupons. These sorts of devices to separate types is something that we'll be talking about after this lecture, but not yet. Arbitrage more easily is accomplished for some goods than others. So expect firms with monopoly power to try to price discriminate. And they'll try to prevent arbitrage among them. Okay. Now there are three broad classes of price discrimination. First is personalized pricing. Second is second degree price discrimination is menu pricing, and third degree price discrimination, what we will be talking about with this video, is called group pricing. Okay. So third degree price discrimination. We've got three features. First, an easily observable characteristic by which monopolists can group consumers according to willingness to pay. The monopolist can prevent arbitrage across the different groups. Again, we will assume this, and this is something that can complicate group pricing. Different prices to different groups, but all consumers within a particular group are quoted the same price, and all consumers within a particular group are free to buy as much as they like at that quoted price. Okay, so that's why it's called linear pricing, because the total expense is basically linear in the price. You're facing a constant price, and each unit that you buy, you basically pay that price, assuming you're part of that group, right? And then again, we are assuming you are observable. Your membership in this group is observable, and you cannot arbitrage. So we've got this observable characteristic, which is a proxy for differences in willingness to pay. Once groups have been identified, consumers for whom the elasticity of demand is low or inelastic should be charged a higher price than those for whom the elasticity of demand is high. So this is exactly like what we've learned in the simple monopolist case. The more inelastic market demand is, the higher the markup, the higher the price. Okay, all things equal. So that result is also applicable here, as you will see in a moment. All right, so now we've got this example. So we've got demand in the United States and demand in Europe for this good. Again, we're saying that we can identify people or consumers from the United States and consumers from Europe. Okay, in an international trade example, this is definitely possible. It's also possible for arbitrage to be outlawed. So if you do not have the right to sell the product, then it's very difficult to do a cross-country sale of a product for which you have no right to sell it. So it will be very difficult, or it will be very rare to be able to do that at a large enough scope. So in this case, we've got an interesting example of sort of global third-degree price discrimination, Europe versus US. Now you've got the marginal cost of providing this product, which is a book of 4, with non-discriminatory pricing. Okay, aggregate demand at each price, you just add the two market demands horizontally. So how you do that? Well, you invert each one, which will give you this. And note that when price is less than 36, this demand is positive. Okay, that makes sense. Because look at this. If price is 36, quantity is 0. But when price is less than 36, that's when quantity is greater than 0. You can see it from the inverse demand curve most clearly. And then for Europe, it's when price is less than 24 when Europe starts purchasing. Okay, so that affects your aggregate market demand, because for aggregate market demand, you have then two regions. First, if the price is higher than what Europe wants to buy it for, then aggregate demand is simply the US demand for these prices. And again, their choke point is when the price is 36. When the price is higher than 36, not even the citizens or consumers from the US will buy. When the price is less than 24, both of them will start buying. So now it's the sum of both of these things, which is 9 plus 6, it's 15. 1/4 plus 1/4 is 1/2, so that's why it's negative P over half. for prices less than 24. So you could invert this into the inverse demand, which is our normal use case for this. So price equals 36 minus 4Q. Again, that's just US when the price is in between 24 and 36. But when the price is less than 24, it becomes the inverse of this one, which is 30 minus 2Q. Okay. So a couple of things I wanted to point out. First, you can think about it not in terms of price, but in terms of quantity. So you can see here, for example, that if price is equal to 24, then price, if you can look at this one, price which is 24, divided by 7, that is, price divided by, price being 24 divided by 4, that's 6. Okay, so 9 minus 6, that's 3. So you can think about this in terms of quantity, where the discontinuity, if you will, or the change in the slope is happening in the x-axis, which is q is equal to 3. So specifically, if q is less than 3, then price is sufficiently high that only the US buys. If q is greater than 3, then both will buy here. All right. What else are we doing? Okay, so and the other thing I wanted to show is, or to talk about, is that look at this part here. This in the coefficient, which is 4, and the coefficient down here, which is 2. The more consumers there are, typically the more flatter the demand curve is, the more elastic it is. Okay, so that's going to show itself there. So there's going to be a kink at prices 24 or quantity is 3. All right. So now let's go here. And I wanted to show you the demand function first before going to marginal revenue. So here you've got the demand in the United States. Okay. When quantity is 0, this is 30, what's that again? 36. Okay. And in Europe, when the quantity is 0, this is 24. I want to say 24. Okay. And then here's not really a discontinuity. The discontinuity is down here. But this is a change in the slope. If the price is between 36 and 24, then here is your demand, which is essentially the demand from the United States. When the price is now 24, Europe starts buying, and then here is our slope, which is flatter than if only one country, consumers from one country is buying. So here is your aggregate demand, which will change, whose slope will change depending on the price, because the price will dictate how many people will buy, from which group will buy. All right, so now let's talk about marginal revenue. You have marginal total revenue and then take the derivative, or you just take the demand curve and then take the double the slope essentially. And here are the quantity levels for which you have the switching between marginal revenue. If quantity is low or if price is high, then this is the marginal revenue basically from the US, right? It becomes even steeper, -8 from -4. And this one is when both of them purchase, then the slope becomes -2, which is double -4, which is double -2. So in class, we will try to solve for all of these things, the profit maximizing quantity and price. And at this price, which is 17, MR of the last book sold in Europe is greater than the MR in the United States. Transferring some of the books sold in the United States to the EU market will lead to an increase in profit. So I'd like to, in class, you should be able to interpret this sentence. Why is that? Okay, you should be able to understand what a difference in the marginal revenue is, basically. Okay? All right, so now we've got this situation for the uniform price. Okay? So in this case, if the marginal cost is 4, it will intersect the marginal revenue of the aggregate demand here at this level, 6.5. The price is 17. And then you can read from each country's demand curve at price 17, how much quantity each will consume. So because if it's a uniform price, again, because of the term uniform price, the price coming from the aggregate demand function is the price faced in Europe and the United States. So in this case, we are not yet seeing price discrimination. This is the uniform price case, when the monopolist tries to maximize over the aggregate demand curve instead of being able to maximize per group. All right. Now let's talk about discriminatory pricing. So instead of being able to maximize only over the aggregate demand or aggregate marginal revenue, now because we're assuming that they cannot arbitrage, and again, we can identify US versus EU consumers, we can now set a different price for each group. So a necessary condition for profit maximization is MR is equal to MC in each market. So you do that, and we shall try to do this in class, which will give you the following. United States is 4, Europe is 2.5, United States has a higher price, then Europe has a lower price of 14. Okay, the aggregate profit is 89 million. Okay. So here you've got that situation where in each place you would want to maximize by setting marginal revenue equals marginal cost in either country. And you've got 14 as the price in Europe and 20 as the price in the United States. All right, so price and elasticity of demand. An important property of linear demand curves, elasticity of demand falls smoothly from infinity to 0 as we move along the demand curve, and it is equal to 1 midway. For any price less than 24, the elasticity of demand in the United States is lower than the elasticity of demand in the EU. Okay, so what if marginal cost is not constant? What if marginal cost is growing like this in terms of output? Okay, then the slope is 1/2. So the next figure illustrates the profit maximizing behavior without price discrimination. So let's look at it. So in this case, you've got, again, a uniform demand. Marginal cost is rising. You get the intersection with marginal revenue, and the quantity is 6.5. The price is still 17 in this case. And then you've got uniform prices. So each country would produce or sell this amount and this amount. Okay. So let's talk about implementing price discrimination in this case. So you've got with price discrimination, you have marginal revenue in this case. Okay. Summing gives you an aggregate marginal revenue, which will be QQ. Okay. If you invert this, it will give you the following, right? For Q less than or equal to 1.5 and Q greater than 1.5. Then equate marginal revenue or aggregate marginal revenue here with marginal cost. Okay? To identify the equilibrium aggregate quantity and marginal revenue. So here you would have 30 minus 4Q, which is your marginal revenue, okay, equals 0.75 plus 2Q, which is your marginal cost, which yields 6.5 as your quantity and the equilibrium marginal revenue, which is 4. So identify the quantities in each market by equating individual marginal revenue with equilibrium marginal revenue and marginal cost. So in the United States, this is your marginal revenue, and then that's equal to 4, okay? And then you're able to determine what the quantities are, okay? And in class, we shall identify that. Identify the equilibrium price in each market from the individual market demand curves, which leads to a price of 20 for the United States and 14 in the EU. Okay, so this is just a picture of exactly what we were talking about. Here you've got aggregate marginal revenue, and you're equating it to marginal cost. Okay, and then this is how you would get the quantity here in the aggregate, which is 6.5. Okay. So how would you then proceed to know the prices individually? Well, this would also give you the level of marginal cost, which you would look at, equate marginal cost to marginal revenue in Europe and marginal revenue in the United States, and that will give you the individual quantities here and the individual prices here. Okay, so this is exactly the same logic as the math that's described here. All right, so two simple rules to guide the monopolist pricing behavior. MR must be equal to the last unit sold in each market. So MR must, for Europe, must be equal to US, or Group A is equal to Group B. And marginal revenue must be equal to MC, where MC is measured at the aggregate output level. When both markets are active, aggregate MR is identical with the two pricing policies, so equating marginal revenue with aggregate marginal cost must give the same aggregate output. However, price discrimination is more profitable in that it allocates the output more profitably in the two markets to ensure the marginal revenue on the last unit sold in each market is equal, compared to the uniform price equilibrium. Okay. Now let's discuss price and elasticity of demand. So marginal revenue in market I in terms of price and point elasticity is the following. So this is very reminiscent of something that we've already learned. Marginal revenue is essentially this thing, okay? And in two markets, remember, this is the key optimality between markets. Your marginal revenues must be equal and should be equal to marginal cost of serving the entire or the aggregate market. So because these two things should be equal, you can equate them and you can get the ratio of price in good 1 of group 1 relative to price in group 2, and that is essentially this ratio of elasticities of demand. And you can see that the price will be lower with in the market with the higher elasticity of demand, or the relatively higher price elasticity of demand. When consumers are price sensitive, the strategy of lowering price can actually raise the monopoly surplus because it brings many additional purchases. Okay. All right. So here we'll just quickly talk about product variety. Many examples of what it looks like price discrimination or group pricing arise when sellers offer differentiated products. Okay. A firm with market power increases its ability to price discriminate by offering different varieties of the same product. Okay. And by versioning the product, the monopolist is able to solve the key identification and arbitrage problem. Okay. So when it comes to third-degree price discrimination, companies offer different varieties of the product as means of having their customers self-select into different groups. So these are the screening devices or the screening conduct that we were talking about earlier. So one way they could do it is crimping their product or deliberately lowering the quality of their product to enhance the ability to price discriminate. So another way is net prices are different. Lower quality product sells for a lower price, yet because it starts as a high quality product and then requires the cost of crimping, the lower quality product is more expensive to make. All right. And this is an important topic, the third degree price discrimination and welfare. So does price discrimination worsen or reduce monopoly distortion? Okay. So let's talk about a very simple example here where you've got discriminatory prices P1 and P2, and PU is the uniform price. Okay. So market 2 is the strong market, wherein the price is higher under discriminatory prices, and market 1 is the weak demand market, where price 1 is less than the uniform. Okay. So the changes in quantities are the differences between discriminatory versus uniform output. Okay. So clearly, because price in good 1 is less, right? Q1, the change in Q1 is greater than 0, and the change in Q2 is negative. Okay, because that's because the price of P2 is higher than in price uniform. Okay, so now we can calculate or estimate, I should say, the change in welfare. So the change in welfare is just the change under the under the demand and above the supply curve, right? But here, what we're trying to do is trying to do something very interesting, right? Because instead of calculating exactly the area under the demand curve as quantities and prices change, okay, so in this case, as we're moving from uniform to lower P1, Q1 change in Q1 is positive, right? As we said earlier. Okay. And as we're moving from uniform to a higher price, change in quantity 2 is negative. But instead of looking under the demand curve and above marginal cost or average cost here, and instead of doing the same thing here, we're doing a little something different. This shaded rectangle represents the upper limit. Okay, it's actually an overestimation of the benefit of reducing prices or increasing output. Okay. Meanwhile, this one, and that's the gain, which is an overestimation of the gain. And this one, on the other hand, in the strong market, when prices rise from uniform to discriminatory, you lose this rectangle and the L here, but you're only trying to look at this one, the L. So this is a lower bound. It's the least amount of loss given an increase in price. Okay, so that's how we interpret these numbers. And that's why this gain is the high estimate and this L is the low estimate. So that means if there's ever a positive number here, then that is sufficient for you to see benefits from moving to differential or discriminatory prices. Okay. The usefulness of this method is seen here in this calculation. So if you'll note that you're trying this area here is just this gap here, which is the change in x1 or q1, and this gap here change in q2, but it's multiplied by pu over minus mc. So the height of the rectangles here are the same because pu is uniform, and then mc is assumed to be equal in both. Well, it's not assumed because of maximization; it will be equal. Then pu equals minus mc times the change in quantity. So these heights here are the same for both. And you can see it here that this product, this difference here is the same as this. So you can basically add them together and pull out this gap here. And if you extend to end markets, then you are summing over the changes in output. And you're multiplying it by the same number, which is the gap between the uniform price and marginal cost. So there will be gains if the change in quantity on net is higher, right? Is positive. And you cannot guarantee increase in welfare if this is 0 or negative. Okay. So remember, this is sort of like a biased measure because this is the most largest possible gain. Okay. An exaggeration of the gain. This is the lowest possible loss. So in order to see a positive number here, what you need is on net a change in quantity. Okay. So a necessary condition for third degree price discrimination, because it's necessary because this is the highest gain and this is the lowest possible loss. To increase welfare is that it increases output. Okay. So even in this sort of biased measure, it will be positive, the welfare gain will be positive if the change in quantity is greater than 0. And that result you'll see over and over and over again. That in price discrimination, welfare will generally be higher, if total output under discriminatory pricing is higher than under uniform. If this change in QI for all the end markets is greater than 0, then that can guarantee, and it's a necessary condition, it will guarantee that price discrimination is superior to uniform pricing. Okay. So this is one handy way of doing it, but it's a necessary condition, right? Um, if you knew what the demand curves were, you would, for example, not include this upper area here. You would just do the area under the demand curve above the marginal cost line. And in the strong market case, you would include this and you would include this triangle here. Okay, you would have an exact measure of the welfare loss or gain from a move from uniform pricing to discriminatory pricing. Now, with linear demands, non-discriminatory output is equal to discriminatory output. So that means the total change in quantity is zero. Thus, third-degree price discrimination must reduce total welfare. Increase in profit is more than offset by the reduction in consumer surplus. Now, there's a caveat. The price discrimination may make it profitable to serve markets that will not be served with non-discriminatory prices. Okay. So if you remember, back in the example in US and Europe, under uniform pricing, both US and Europe were served. And under discriminatory pricing, both Europe and US were served. However, it's possible that under discriminatory pricing, it won't even serve the low demand group, right? Because their demand is so low that the quantity, the equilibrium monopolist quantity is in fact zero. So um, if price discrimination makes it possible to serve markets that will not be served when the price is uniform. So when the price is uniform, the end price will be so high, such that the people in the low demand groups will not even buy it. Then price discrimination is clearly superior because it allows you to sell to lower demand groups. Okay, which basically dovetails to the original criteria for an increase in welfare, which is you have to have an increase in total output. And in this case, if you sell to more groups, then you will definitely have an increase in output. So here we've got an example for North America and Africa, where alpha is sort of a measure of how much lower their demand is relative to the United States. Okay, so this alpha is something we're interested in to figure out what the size of it is in order for a uniform price to serve both North America and South Africa. Now, the marginal cost is constant at 20. With no PD, that means uniform price. You invert the demand equations, aggregate demand, and you get marginal revenue. You equate marginal revenue with marginal cost, and that gives you an equilibrium output of 30 plus alpha 50, and a price of 35 plus 25 alpha. So for the two markets to be served, it must be that this price here, which is the equilibrium price, is less than 100 alpha, because 100 alpha happens to be the max price for South Africa. So it must be that the uniform price is less than this. So for both markets to be active without price discrimination, alpha must be greater than 0.466, which is almost 1/2. So with price discrimination, for a monopolist to be willing to supply the African market, all that is needed is that the reservation price alpha 100 be greater than the marginal cost of 20, or alpha is greater than 0.2. Okay. So with price discrimination, alpha has to be greater than 0.2. With uniform, alpha has to be 0.46. So in that sense, it's easier or more likely for Africa to be supplied if they are allowed to set a different price for the United States and Africa, a lower price for Africa and higher price for the United States. All right, and that ends discriminatory pricing, price discrimination with linear pricing.